Okay, so this question here, risky kinematics, has to do... Okay, so this next question here, risky kinematics, we've got 3 patients, all suffering from Parkinson's disease, and we can do a simple biomechanical assessment to put them in a risk category for falls. Knowing from best evidence in the area in biomechanics that average step length is an indicator of risk of fall. So lower step lengths can certainly indicate a higher risk of a fall for that patient. So we want to assess these 3 and we get them walking through the lab, a 10-meter space in the lab that they're going to be walking through, and we're going to collect the time of their walk and use some data capture, so some video software or a mat that we might have instrumented to get their number of steps during that trial, and we'll get their average number of steps over maybe a couple of trials, and what we're looking for is their average step length. Now, a lot of people read this question and they start to get a little confused about how to calculate these cyclic aspects and which data to use. The calculation is actually really simple. But as with most situations that we actually find in the real world, you have a bit more data here than you actually need. So you've got to think about what you need specifically and how to make that calculation. In fact, in real life, you don't just usually have a little bit more data, you have a wealth of data out there. So a big aspect of understanding biomechanics is figuring out what's important. So here we're asking for the average step length. So step length is a product of the distance and the number of steps within that distance. So there's an equation there, but it's also fairly common sense. If I told you that someone took 20 steps in that 10 meters, then you would think, oh, okay, well, they've taken twice as many steps as meters, and therefore their step length would be around half a meter, 0.5 meters. And so what you're doing there is basically taking displacement, dividing it by steps, and getting your average step length. And that's exactly what the equation is. So Paul's average step length is just 10. That's the space divided by 21.07. So 0.5 or 0.47. And if we look at the risk category, that would put Paul at a high risk category. If we calculate Roger's average step length, it's 10 divided by 16.5, so 0.61, which puts Roger at a low risk. And then Stephen, 10 divided by 19.03, 0.53, putting him in the moderate risk group.